Good evening, class. This is A.T. Burnett coming from the U.S. Virgin Islands on vacation, so I will not be available for this week's sync session. I've jumped directly into the overview of the lesson. However, we're going to discuss different security architectures and describe them. Also, provide the best balance between simplicity and security and why. So basically, we define security architecture as a view of overall system architecture from a security point and how the system is put together to satisfy security requirements. In addition, just running through some of these bullet points before we go into the different models, security architecture, design the principles are reported clearly and in-depth security controls, specifically in general documentation, independent documents. Basically, this is the models are based upon the network architecture and equipment that you have available to use in order for your security. Ideally, we would safely assume that most of the time people have some type of firewall, some type of router, and some type of switch to make these interconnects. And the security posture of those devices basically define what model can be used and how it can be used effectively. So the two models, the two popular models we have is the BIBA integrated model. It was developed by Kenneth, of course his last name is BIBA, about 1975. Basically, it was developed by the U.S. government. How ironic how the government has a kind of play in everything that we use, even going as far as in their standards. But and this is a kind of multi-level security policy. And I know for a fact the military use that, and I'll kind of go on depth to that with another slide. Another one is also the Curtis Wilson integrated model. This presents a methodology of Pacific analytics integrated policies for data systems. So basically, the BIBA model is broken up or defined based upon different layers or networks. In concept, basically, they call the first one your NIPRNet, which is your on-class network. And these networks are defined and segmented by each network type, and no network overlaps to another network. So basically, coinciding with your clearance, basically any user, probably in the military, who comes on, will be able to get a NIPR account. It's just a basic email account. As your clearance level goes up, you in turn will get a SIPR account. And if you really are special, you get what they call a top secret SCI. And if you notice that the top secret SCI network works across all of DoD. So if you're in the Air Force, Army, Navy, Marines, it doesn't matter. You're going to rock this particular network for any type of top secret SCI. These networks operate with my first experience dealing with what was those things called? I can't believe it. I drew a blank. I'll come back to that. But basically, there's specific equipment outside of firewalls, routers that are used that does not allow them to overlap and send communications down one pipe and one pipe only. Okay, the Clark Wilson is a little different. This one takes the model of they have a transformation process basically. The process is simple operation and can be performed. So it's basically your standard operations if it's authorized. The constraint data is basically saying if this is authorized data, it's going to go through. You're going to make it, it's going to be allowed to go through. However, if you don't have data that is authorized, you have to go back to the integrity verification process. And then that process will determine whether or not the data can be sent. It doesn't, they both are working upon and type of integrity and make sure data is going sending point to point. However, this one has kind of like their integrated verification process, which allows a middleman in source to make sure that the data is good to go, and then it can go down that specific line. Kind of along the lines of TCI IP. Of course, you want to send data, it's going to send, but without that verification IP, it's not going to send. All right, so when we talk about the access control model, which is something a little different, these models are used to ensure like on firewall policy. So you use the manager access control. That is a resource classified. They use certain labels or clearance labels can send information. So it kind of goes back to your BIBA model. If you have a top secret, it's going to go down the top secret line. If you're accessing the secret network, it's going to go down the secret line. But those two layers do not overlap. When you go down to your role-based access, role-based is basically kind of explanatory. Whatever your role is and what you're authorized to do, that's what you're going to do. Your disciplinary access control model kind of uses their ACLs, which a lot of people use in firewall policy. Policy not written in firewall policy, not going to work. And your rule-based kind of also aligns with your ACL policy as well too. So basically, if the policy is not in the firewall, policy is not going to it's not going to work. Information is going to get denied. Separation of duties. This is kind of like one that's basically used in a little resource kind of used in banking. So basically, you have two type of different variants. You have a static and you have a dynamic. Basically, a static role is someone who does the same rule all the time and does not change. A dynamic role works within the same domain. However, sometimes you may have to make a judgment call or a decision based upon what is required to be done, but it's still within your same domain. So that is my presentation, about 6 minutes 30 seconds, and I hope you guys have a great day, and I will catch you guys in the next SureSync. Thank you very much.